Hi everyone. So this is your first lesson for Unit 10 on adding and subtracting rational expressions. With adding and subtracting, we want to remember rational expressions are really just fractions. So when we are adding and subtracting fractions, one thing we need to remember is that we need a common denominator. So we are going to first look at just regular numbers. So we have 3/7 minus 5/6 plus 2/3. So we want to think of a number for our common denominator that it is all three of those numbers are divisible by. So for instance, I might take the two largest and multiply them together to get 42. And then I want to see if the third denominator, 3, is also if 42 is also divisible by 3. And it is. So 42 is going to be my common denominator. So I'm going to take 3/7 and multiply it by 1 because I can do that. It doesn't change what it is. But I'm going to rewrite 1 as 6/6 because that will get me that common denominator of 42 minus. Now I'm going to take that 5/6 and I'm going to multiply it also by 1, but I'm going to multiply it by 7/7 because that will also give me that common denominator of 42. And then I'm going to take the 2/3 and multiply it by the common denominator as well. And that would be, let's see, I'm going to multiply this one by 14/14 because 3 times 14 in the denominator will also give us 42. So now we can simplify. We get 18 42 minus 35 42 plus 28 42. So now we're just calculating that to see what we get. And we get 11 42. Remember, the denominator stays the same when you are adding. All you're doing is adding and subtracting the numerators of each. So let's skip down to see what this looks like with actual rational functions. So one thing to remember is that if you do have addition in the numerator or subtraction, you can rewrite it as two separate fractions being added together or subtracted. So for instance, I can rewrite a plus b over c as a over c plus b over c. Notice they have a common denominator. So I don't have to just add things together. I can split them apart as well. So same thing goes with the second one. A minus b over c is a over c minus b over c. Noticing that they have the same denominator. All right. So if there is not a common denominator, we must create it. So the first thing we're going to do is factor the denominator of that first fraction. So we've got x times x gives us x squared. And we're looking for two numbers that multiply to give us negative 15, but add up to 2. So that's going to be a positive 5 and a negative 3. So we can see that the denominator on the first one does have something in common with the denominator of the second fraction. They both have an x minus 3. But to make the denominators the same, I'm going to multiply this entire second fraction by x plus 5 over x plus 5, because then our denominators will be the same. So my first one, x plus 5, remains the same, but now the denominator is in factored form. And the second one, we have 2 times x plus 5 in the numerator, and the denominator is x minus 3, which was already there. You can see it highlighted here, times x plus 5. And I'm not going to ask you to actually multiply them together at this moment. Notice that our denominators are the same now. And that multiplication is commutative, so it does not matter whether the x minus 3 is first or the x plus 5 is first. All right, so now we're going to actually add them together. And we are going to rewrite this one as 1 times x plus 5, because notice how we have 1 x plus 5 plus 2 x plus 5, which would give us 3 x plus 5s. And in the bottom, we still have x plus 5 and x minus 3. And this helps us out a lot because if we have something in the top and we have something in the bottom, they can cancel out because x plus 5 divided by itself is equal to 1. Anything divided by itself is equal to 1. So our remainder on top is 3 and the bottom is x minus 3. And this is as simplified as it gets. So let's look at another example. Two of the denominators on this one are very similar. One of them is x minus 2 and one's 2 minus x. So what we're going to do is take this whole one and we're going to multiply it by negative 1 over negative 1. So let's see what that gives us. 3 over x minus 2 stays the same, but now we have negative 4 on the top and negative 2 plus x on the bottom. Because remember, if we're multiplying that entire denominator by negative 1, it changes the signs for both the 2 and the x. And now, believe it or not, these two actually mean the same thing. All they've done is switched places. X minus 2 is the same thing as negative 2 plus x. The x is still positive and the 2 is still negative. All they've done is swap locations. So those two have a common denominator already. So let's go ahead and add the first two together. That might make it easy for us. The denominators get added, or numerators. 3 plus negative 4 is negative 1. And the denominator, you can write it either of those two ways that are highlighted, but I prefer to have the x first. And let's bring this guy down. Now these two have to have a common denominator, and they currently do not. So we are going to multiply this entire fraction, by the denominator of the other fraction, which is x. So we're going to multiply it by x over x. And this fraction, the second one, is going to be multiplied by the denominator of the first fraction, which was x minus 2. Let's see what we get. For the first fraction, x times negative 1 is negative 1x. And in the denominator, we're going to leave it as x times x minus 2. You don't need to actually distribute that x to both the x and the minus 2. Now let's do the top of the second fraction. 1 times x minus 2 is x minus 2. And in the bottom, we're going to leave our denominator as x times x minus 2. All right, so let's add some of these things together. Let's add the numerators. Negative 1x plus positive, and remember, this has a 1 in front of it. So negative 1x plus positive 1x is 0. There are no more x's in the numerator, just a negative 2. And the bottom remains x times x minus 2. Really think about these, guys. You need to have a common denominator. And how are you going to get that common denominator? What are you going to multiply by on each side? And reminding yourself that you're multiplying by that value over itself, like this highlighted x over x, because anything over itself is really just multiplying by 1. And that's okay. We can do that anytime we want. Because remember, multiplying by 1 means we're not changing the value of the expression at all. Anytime you multiply by 1, really it stays the same. So that's okay to do that. So let's go ahead and move on to the next page. I'm not super concerned with this top section of the notes. Okay, so we're going to move on to some of the examples. With ones like this, we want to make sure to factor first. Factoring is going to be our best friend here. So in the numerator, we have 7x minus 1, and we're going to factor the denominator of that first fraction. X times x is x squared. We're trying to find two numbers that multiply to give us negative 3. Well, that's easy. 3 and 1, but the question is which one's negative? Remember, they have to add up to that middle term, negative 2. So that means the 3 is going to be negative and the 1 is going to be positive because they multiply to give us negative 3, but add up to negative 2. Now we're going to look at that second rational expression, the 6x in the numerator, and we're going to factor the denominator. So x times x gives us the x squared, 2 times 1 gives us 2. But to get that negative 1 in the middle, when we add them together, the 2 has to be negative and the 1 has to be positive. Now looking at these, it looks great. It looks like, okay, they both have x plus 1 in the denominator. Yay. But the problem here is that we do not have the other ones. We have x plus 1 in common, but they don't have anything else in common. So I am going to multiply this first rational function by the other rational function's denominator that they didn't have in common. So I'm going to multiply by x minus 2 over x minus 2. Okay? And I am also going to do the same thing on this side. I'm going to multiply by the x minus 3 from the other fraction's denominator. So let's see what that looks like, shall we? So take a look at the steps that I just did, okay? When multiplying the numerators, I left them as binomials, x minus 2 times 7x minus 1. And I did the same thing on the right. I left the 6x times x minus 3 in parentheses. I didn't actually multiply them together yet. But now the denominators are the same. Note that these three factors in the denominator are the same as these three factors in the denominator. So that's a good thing for us. And even though they're not necessarily in the same order, that's okay. So now we need to, those two things highlighted in yellow, the numerators, we're going to actually multiply them together to get the next step. And that's how we move from here to here, is we multiplied these two together. You can use box method, FOIL method to multiply them together. And then we distributed here to get this. Now we're going to actually subtract the numerators. So we've got 7x squared, keep in mind there's a minus in the middle, 6x squared. Okay, so 7 minus 6 is 1, or just x squared. And then we're going to do the same thing with the x's. So here we have negative 15x, and then we're minusing negative 8x. So minusing a negative, remember, is the same thing as plus. A double negative is the same thing as plus. So what we really have is negative 15x plus 18x, which is 3x. And then lastly, we have the constant here. That is 2. There is nothing on the right fraction that would combine with it. And our denominators are staying the same. Remember, the denominator is the same for both of them. So it doesn't matter which order you write those three parentheses in. Now our last step really is to try and factor that trinomial on top that we've created and see if it cancels with anything in the denominator. So I'm going to go ahead and factor the numerator for us. Now that I've factored it, you can see that x plus 1 divided by x plus 1 is 1. They cancel each other out, leaving us with x plus 2 on top and x minus 2 times x minus 3 on bottom. Nothing else cancels out. It is as simplified as it can be. Now what I'd like you to do is go ahead and try this one on your own. Pause the video, give it a try, and then unpause the video to see if you got the correct answer. All right, so hopefully you're checking over this. Notice that I did rewrite the 4 plus x in the denominator as x plus 4 because it means the same thing, but it's in more of standard form where we would write the values that have the highest degree first. So x has a degree of 1, whereas 4 only has a degree of 0. So we're writing them in standard form. I multiplied the first fraction by x over x and the second fraction by x plus 4 over x plus 4. Notice the denominator stayed as x times x plus 4. I did multiply them together by distributing. I left them that way just in case we have something to cancel out later. And then keep in mind that when you are subtracting, notice I highlighted it in blue, we're subtracting all of these, okay? So make sure that you're subtracting each of those from the x squared minus 5x. I